Okay, so this topic is gonna be about the inverse matrix. So it's one of the biggest topics in like introductory linear algebra. But the good news is that it's actually quite simple. At least like to learn and to get the hang of it. So the entire theory, as simply as possible, is I want us to think about regular numbers first, right? So we already know that 5 times 1 over 5 equals 1. We already know that. So the number 1/5 is called the inverse of 5 technically because it undoes multiplying by 5. So matrices work the exact same way. If we have A, and if we have A as a matrix, then the inverse of A is written as A inverse. So the inverse undoes multiplying by A. So we have our goal. We want A times the inverse of A equals I, and A inverse times A equals I. So I will be our identity matrix. Now we ask ourselves, wait, but what is an identity matrix? I'm glad you asked. So the identity matrix is like the number 1 for matrices. So for a 2 by 2 matrix, I will equal 1, 0, 0, 1. Notice that the 1s are on the diagonal and the 0s are everywhere else. So if we multiply any matrix by the identity matrix, nothing changes. So for example, A I equals A. And remember, A is just any matrix out there. So now we come to the question, hey, why do we even need an inverse? Well, I'm glad you asked. Suppose AX equals B, and we want to solve for X. We must multiply both sides by the inverse to solve for X. So we have A inverse AX equals A inverse times B. Since now we have our property, right? Since A inverse times A equals I, from this, we can get that I times X equals A inverse B. Now, since I times X equals X, because anything multiplied by the identity is just that anything, we have our answer as X equals A inverse B. So the inverses let us solve matrix equations. That is why we need an inverse in the first place. Now we move on to our question of why does an inverse even exist? Good question. Not every matrix has an inverse. So a matrix only has an inverse if the determinant of the matrix does not equal 0. If the determinant of the matrix equals 0, there is no inverse. Now we're going to get on to our formula. So suppose you have a matrix. You have a matrix of A, B, C, D. Okay. So the determinant of a matrix is A times D minus B times C. That is the determinant of any matrix, any 2 by 2 matrix. So if the determinant is not 0, then our inverse will be 1 over AD minus BC. So 1 over our determinant. And then we're going to have D, negative C, negative B, A. So this is our formula for an inverse. So this is the only formula that you will usually memorize for like an intro to linear algebra, this one. So screenshot it, like keep it close, keep it under your pillow. Okay, so I want to tell you like, uh, I want to show you like an easy way to remember it. I know you have like a formula sheet, but this is gonna be just like an easy way to remember it. So when we're given a matrix of A, B, C, and D, we must do three things. Step one is to find the determinant. So our determinant will be AD minus BC. Our determinant is like this minus this, right? Step two is to swap A and D. Swap A and D. Step three is to change the signs of B and C. Change signs of B and C. And then we multiply everything by 1 over the determinant of the matrix. So this is how to easily remember it. This is just something I like had to drill in my brain physically. So now let's look at some examples of how to do this whole concept and topic. So our example one is we must find the inverse of this matrix, inverse of 2, 1, 3, 2, whatever. Step one, find the determinant. It's going to be this minus this, right? So it's going to be 2 times 2 minus 1 times 3, which just equals 4 minus 3, which equals 1. So great, since this isn't 0, that means that the inverse exists in the first place. Equals 1. Now we must swap the diagonal. So 2, 3, 1, 1, 2. This becomes 2, 3, 1, 2. In this example, the diagonal entries are both 2. So when you swap 2's, it's just going to be 2 and 2 again. Step 3. Change the signs of the off-diagonal entries. So the off-diagonal entries are the 1 and 3. So we're going to change the signs of that. So this will be 2, -3, -1, 2. Step 4, we multiply by 1 over 1, because 1 over the determinant is just going to be 1 over 1. So the whole inverse matrix is going to be, we don't need to do the 1 over 1 times, because that's just going to be the matrix itself. So the whole matrix of the whole inverse matrix is going to be 2, -3, -1, 2. Wow, that's it. We did it. Now I want to show you that I want to show you something, but this is not something you necessarily have to do on your exam because you're time constrained, but we can actually check our answer by multiplying them. So we have our original matrix, right? 2, 3, 1, 2. And then we have our inverse matrix, 2, -3, -1, 2. So to multiply these, we do our top left first. So this becomes 2 times 2 plus 1 times -3. So then this is just like, this is another thing of how to multiply matrices. Our top left is always going to be like this. I will go through another video of how to like actually multiply matrices more in depth, but for now, this is just for the sake of checking that what we did is correct. Equals 4 minus 3 equals 1. Our top right will be 2 times -1 plus 1 times 2. And it's going to be 0. Our bottom right will be 3 times -1 plus 2 times 2 equals 1. So our whole result will be 1, 0. Wait, I forgot to do one calculation. So we got, oh, I forgot to do our top right because there's 4 parts to multiplying a matrix. So this is the top left. I forgot to do our bottom left. Okay, so our bottom left is 3 times negative 1 plus 2 times 2, which equals 1. So our whole result will be 1001. So this is the top left, this is the top right, this is the bottom left, and this is the bottom right, and this is our result. So since we got the identity matrix, the inverse is correct because this will always be the identity matrix. This is something you don't really have to do in exam. This is just checking that what we got is correct, and you should only do this if you like are unsure and you have some extra time. So now we're gonna look at example 2. Whoops. One second. Okay, I cooked something up. So now we have an example 2. We're gonna have to find the inverse of this matrix. 4, 1, 2, 3. So step 1, find the determinant. This minus this, right? So it's gonna be 4 times 3 minus 2 times 1, which will equal 12 minus 2 equals 10. Step 2, swap the diagonal entries. So when these are gonna be swapped, it becomes 3, 1, 2, 4. Step 3, swap the signs of the off-diagonal entries. So these are the off-diagonal entries. We swap the signs from a positive to a negative. So it's going to become 3, negative 1, negative 2, 4. Now, 1 second. Now we have this, so we multiply by our 1 over the determinant. So our 1 over the determinant is just 1 over 10 because our determinant is just 10. So our final answer will be 1 over 10 times 3, negative 1, negative 2, 4. Now, another answer that's acceptable, but you shouldn't have it like that because it's a bit annoying, is that you can multiply the 1 over 10 entry by every term in our matrix, but don't do that. That's just a bit annoying to read, but it is another way to write the answer. But this is going to be our answer. Now let's go on to another example, example number 3. So we're going to find the inverse of this matrix. 2, 1, 4, 2. Step 1 is to find the determinant. So this minus this, 2 times 2 minus 4 times 1. That's going to be 4 minus 4, which is 0. And remember, since our determinant is 0, no inverse exists. So this is all we have to do. There is no inverse matrix to this problem. Haha, trick problem. So now I'm going to talk a bit about like a summary of everything we've done. So step 1 is to compute the determinant, right? So step 2 is that if the determinant is 0, then just stop. Like there is no inverse matrix there. Step 3 is to swap the diagonal entries. Step 4 is to change the signs of the off-diagonal entries. Step 5 is to multiply the new matrix by 1 over the determinant. So I'm going to go over some really common exam problems that you might see. Problem 1, find the inverse of this matrix. So our determinant is going to be 5 times 1 minus 2 times 1. Remember, this minus this, which is going to be 3. So our inverse will be 1 over 3 times 1, negative 1, negative 2, 5, after doing all the steps. And I'm going through the steps really fast. So in one step, I'm swapping the I'm swapping the diagonals and changing the signs of the off diagonals in one like quick step, because this should become like really like muscle memory to you at this point. Problem 2, find the inverse of 3, 2, 5, 4. So first we find the determinant, right? 3 times 4 minus 5 times 2, which is going to be 2. So the whole thing is, the inverse matrix is 1/2 times, swap the diagonals, 4, 3, change the signs of the off diagonals, -2, -5. That's it. That's the inverse matrix of this. And that's how simple it is. So if there's a one sentence rule to remember that to find the inverse of a 2 by 2 matrix, we must compute the determinant of AD minus BC, make sure it isn't 0, swap the diagonal entries, change the sign of the off diagonal entries, and multiply by 1 over the determinant. So you will have that in your formula exam sheet anyways, but yeah, that's it.